Let's talk about planning a network. Now, before we actually get into building a real-world network or installing a real-world network, there's a lot of things that we have to think about in order to prepare for that, to create a plan and then implement that plan. So let's talk through a couple of those considerations. I'm going to use this floor plan here. Now, that's just a sketch of an office building that'll kind of give us a framework to talk about these different things. So of course the first thing that we need to be familiar with is the layout of the building. What does the building actually look like? Now, since we have a sketch of the building, it's fairly easy to kind of tell. We've got some offices around the perimeter, and in the middle here, this looks like a conference room. We've got a cubicle area over here. The main entrance is down over here with a secretary's desk. Looks like we've got a break room over here, a couple of bathrooms, and a hallway that kind of goes all the way around the offices. So that kind of gives us an idea of what the layout of the building is. Other things that we might want to consider at this time while we're thinking about the layout of the building is this the only floor? Or is there a floor above this one? Is there a basement below? If there's a basement below, we might be able to run some of our networking in that level rather than trying to run it in between all these different offices upstairs. Is there a drop ceiling? Again, that might make our networking a little bit easier if we can hide some cables up in the ceiling rather than having to put them in tubes on the wall or something like that. Okay. So we want to get familiar with the layout. Now, part of the layout is also where are the devices that we're offering service. So you'll notice we've got several offices. Each of these offices has at least one computer in it. Some of them have more computers, like this guy up here has 4 computers or 2 computers over here. Or in the cubicle area, we might have 8 computers all in one office. So we need to start thinking about where are the devices that we want to service, how many of them are there, and what kinds of networks do we need? Are these all desktop devices where we can just run wired networking to all of the different devices? Do we have laptops? Do we have a mixture of both? Do we have tablets that can't use a wired network or they have to have a wireless network? Probably this conference room, for example. People are probably bringing in laptops or tablets or other devices, not lugging their desktops from their offices to the conference room. So this conference room probably needs some sort of wireless networking in it. Another question is, how large is the building? Are each of these offices 10 by 10 or 20 by 20 or 100 by 100 feet? We don't really know without markings on the diagram, but that will be very important as we start to plan our cable runs. Recall that the maximum length of an Ethernet cable is going to be 100 meters from the hub to a node. And so if these are significantly huge offices, which you can kind of tell just based on what's inside of them, that they're not overly huge, but if they were 100 by 100, you might only be able to get Ethernet across 3 of these offices before you ran out of your maximum length of Ethernet. Next question is, where is the networking equipment? Now, in general, we don't necessarily want to disperse our networking equipment across the entire building. For example, let's say that the internet comes into the building, I don't know, maybe into this closet over here. So the internet comes into this closet. We don't necessarily want to then run a couple of lines over and around to these 2 offices and then put a switch here and run 2 more lines to these offices and put a switch in this office and make a few more lines down these offices, put a switch here. No, we'd end up with switches in every 3rd or 4th office, and it wouldn't necessarily be easy to manage. Usually when we're looking at putting together a real-world network, we really want to centralize our equipment. So as much as possible, we need to find a spot that we can put all of that equipment together. Now, I've got 2 closets. They look like closets because there's no desks or anything in there, so probably closets. Here's another large space. Might be an office or an unused office. Might be another storage closet. Not quite sure what those 3 areas are. Since there's nothing in them, they're not labeled, but maybe one of those 3 closets would serve as a good communications room. So let's just say we got lucky. The internet comes into this room here. It's a really nice large room that's climate controlled, air conditioned, centrally located for all of the rest of the building, and we decide we're going to put our networking equipment in here. And we want to make sure is there power for all of that networking equipment. Can we get from this office into all of the other offices with cable, or is this, some weird concrete block wall where we can't actually get in or out of it without going through some pretty hard stuff? So maybe this isn't a good idea for a comm room if that's the case, but we need to start thinking about how do we locate our equipment, how do we get our runs to all these different offices, etc. Another big question is, how much is this all going to cost? How much wire are we going to need to get from wherever our equipment ends up to all all of these different offices. How are we going to get to the wireless access points? How are we going to get power to the wireless access points? And how much is that going to cost now? Another question might be, how much would it cost in the future to add more networking? Maybe this building hasn't actually been constructed yet. Maybe this is a floor plan for a building that they're planning on building in the next couple of years, and they want some networking in it. Maybe we can then go ahead and add in all of our networking plan while there's no drywall on the walls, and it's a lot easier to run things through the walls and to the various offices. That's going to be much less expensive than trying to retrofit new networking equipment into an existing building.
So let's keep talking about putting our plan together. I'm going to use this blueprint of an office building as kind of our hypothetical scenario. So let's just say this is an existing building. It has no networking in it right now. The previous tenants had some sort of a wireless solution or something. They've since moved out. There's no networking in it whatsoever, and we've been asked to get this building wired up. Now, of course, we've started with our considerations of, what's the layout of the building, etc. Now we need to start thinking about, how do we actually get service to all of these different computers? The first thing that we need to know is, where does the internet come into the building? Is there even internet to the building? If so, where does it come into the building? And so we might want to mark somewhere on here where the internet's coming in. Now, in a building like this, in an industrial setting, it's often common that the internet service provider will actually ask you, where do you want the internet to come into the building, especially if they're running a new line, and they'll do their best to actually run it in. Of course, they won't necessarily be able to get exactly where you want to go unless there's an easy path to that. So let's say, for example, that we want to put the comm closet into this room here. Well, there's an exterior wall just beside that, so it's fairly likely that an internet service provider might be able to get that in. However, if we say, well, we actually want our internet in this room here, because there's not a clear path from the outside to the inside of that room, it might be difficult for an internet service provider to actually get their line or their equipment into this room. Of course, we're also thinking, is there power? We need at least one outlet for each of the different networking devices. We might be able to use a UPS or a power distribution unit or a power strip, something like that, to kind of translate one outlet into more. But realize we really want a couple of good circuits inside of our comm closet, especially if we're going to be putting other stuff other than just networking equipment in there. So the question becomes, well, where does it actually come in? So for this building, let's just say, I kind of like this room up here because it's further away from the main entrance, so it's a little bit more secure. If we need technicians coming in and out, maybe they can use this little entrance exit over here. So let's go ahead and call this our comm room. So let's say that our internet service provider is going to bring in our internet right there. So I'm going to mark that, and I'm just going to say this is our demarcation point. So our demarcation point, this is where responsibility changes hands. Essentially, the internet service provider is going to be providing internet to this location across either fiber or cable or some other medium that they're going to bring into the building. In today's world, it's most commonly fiber. They're going to put a device here that translates that fiber into an Ethernet network, and that is where their responsibility ends. They're responsible for making sure that the internet makes it to that point. Our responsibility then becomes making sure that we get that internet to the rest of the building. So there's our demarcation point. This is now going to become our communications closet. Of course, we want to try and keep all of our networking equipment together in this one spot. We don't want to have a switch in every single office, especially an area like this room here. This might be the exception because we've got 8 computers here. We don't necessarily want to have a switch here and a switch over here where we've got 2 people, and a switch over here where we got 4, and a switch over here where we got 3. It becomes very difficult to manage if we have all of these networking devices scattered throughout the business, especially if we decide to kind of combine offices. So maybe we put a switch here that services this office and the office next to it, but the offices on either side are still serviced from a switch inside of this room here. It becomes very difficult to troubleshoot. Well, where is this room actually connected to? If the switch is in this room, can I find it? And it becomes just a little bit more of a difficult process of trying to track down where this equipment is. So this is our demarcation point. We want to stick all of our networking equipment inside of this closet. Now, real quick, what is that networking equipment going to look like? Well, let's think about a typical network. Okay, so we have the internet, which I'll indicate with a cloud.
Okay, so there's the internet. That's going to come into our building. Now, once it gets into our building, the first thing that it's going to hit is a modem. Okay. Now, the modem's responsibility, it's a physical layer device. It's responsible for translating whatever medium this is into an Ethernet network. Okay. So maybe this side is fiber and this side is going to be Ethernet. Right? Now, it's possible that they bring Ethernet into the building. Maybe we don't even need the modem if it's coming in straight as Ethernet. But in typical business scenarios and even home scenarios where this is a cable line or a satellite cable line, something that's going to need to be translated into Ethernet, we need that modem. Now, after the modem, we need a router. The router is going to have a public IP address, something like 74.84.90.120 on the external interface, and then on the inside, it's going to have some internal network address. Okay? Something like a 10./12, something that's actually an IP address within that range. The router is then going to connect to a switch, and that switch is going to be responsible for dividing up that connection to a variety of other devices. Now, realize this is a very simplified model of what an internet connection or the equipment in a comm closet is going to look like. We might have dozens of switches depending on how many devices we're servicing. We're going to stack switch to switch. We might have multiple routers, or we might even have multiple internet lines coming into the building with multiple modems. This diagram also doesn't have firewalls or load balancers or any of the security equipment that we're going to talk about later. But just to give you a quick idea of what's going on here, okay? So the internet's coming in. This is the ISP's job, is essentially internet to modem. That's their job there. Our job picks up with a router, okay? Trying to get the public IP address routed to an internal IP address, and then a switch to divvy up connections. So coming back to our blueprint, that gives you an idea of what's going to be in this room to start with. We're going to have at least a router, and oftentimes there will be kind of a modem router switch combination in smaller environments. In larger environments, we start to break it up for performance. But in this particular scenario, we're probably going to have a router. Because it's a business, we'll probably have some combination of a firewall router living in this room, and then we're going to have enough switches to service all of these other rooms. Now, this becomes the biggest challenge. It's great. We've got an internet connection here. How do I get that internet connection out to all of these other offices, all of these other computers? Right? Now, depending on the size of this building, we could take the easy route. We could stick a wireless access point on one corner and another wireless access point over in the other corner. And if it's a strong enough wireless signal, maybe that'll give wireless to all these devices. Woohoo, we're done, and we can go home. Well, that's not necessarily the proper solution. Again, we've got to start thinking, what are all of these devices? Are they desktop computers? Are they laptop computers? Maybe they're tablets. Maybe this guy here doesn't have a desktop, but he's got 2 laptops, a tablet, and 3 cell phones that he wants to hook up to the network. He's weird. But we need to start thinking, what are our customer needs? What do they actually have in their offices that we need to connect up? Now, in a typical business environment, you're going to be dealing with desktops. And even if all of these desktops have wireless connections, we really want to run wired lines. Wired is always going to be more consistent, more reliable, and typically faster than a wireless connection. The more wireless devices you have in an environment, the more that wireless performance degrades. So in a large environment like this, we really want to have wired drops to as many computers as we can. So let's start thinking, how are we going to do that? So this is our starting point. We've got a demarc here. We need to figure out how are we getting to all of these other offices. And this is where we need to start thinking about, well, what's the construction of this building? Do I have drop ceilings? If we have drop ceilings throughout this entire building, maybe even in the hallway into the offices, usually there's a good foot or 2 of space between that drop ceiling and the ceiling above the drop ceiling. And so we might be able to drill a hole or run some piping out of this room into that drop ceiling, and we can kind of use this hallway as our cable run, and then pop into each of these different offices as we run around that hallway. Maybe we don't have a drop ceiling, but maybe we have a basement beneath this, and maybe it's a crawl space or something where we have access to the ceiling above, and so we can drop down through the floor, and maybe we can run some pipes along the outside wall, come up into each of these offices from down below. But let's say worst case scenario. So worst case scenario, this is a concrete slab that this building is built on. All of the ceilings are finished plaster and lath with crown molding. Terrible situation where we can't run much of anything. Well, then we're going to have to get creative. Let's go ahead and assume a best case scenario, which means that either we have a drop ceiling that we can run stuff through, or we've got a basement below that we can run stuff through. Now, in an environment like this, we're going to have a lot of lines for both safety reasons, interference reasons, and because it's the right way to do it. We're going to want to put all of that wiring inside of a conduit of some sort, some kind of a gray PVC or something like that. So let's say with the basement option, if this room is our demarcation point, with the basement option, we're going to punch through. We might run either a cable track or a pipe along this outside wall, all the way around the building, maybe one leg going around that way, one leg going around this way, run something into the middle over here, and then pop up through the floor. Now, when we pop up through the floor, we're going to want to pop up fairly close to a wall so that we can get that wire into a cable track and get it into a box on the wall. Now, let's talk about an individual office. Okay, so let's say we've got this office here. This one's kind of a weird one in that we've got desks in the middle of the room. It looks like we've got two people facing each other at desks in the middle of the room. The question becomes, where do I put the Ethernet jack in this room? Okay. Got a couple of options. If I'm coming up from below, I might actually be able to put a floor plate right in the middle of the room underneath these two desks. The problem is, what if these two people realize that they don't really like facing each other day in and day out, and they decide to move their desks up against the walls? Well, now their network connectivity is going to stream from the middle of the room off to a desk. And guess what's going to happen? Well, people are going to be walking right through the middle of the room. They're going to break something. Okay? So the question becomes, well, where do we actually want to put it? And a good rule of thumb is think about the door. Okay? Think about where the door is and what the traffic is going to look like. And if we can get the Ethernet port or the network connection port as far away from that door as possible, we're less likely to get into issues where people are walking across that cable. Okay? So if we were to go for this corner, for example, this corner might not be the best option for this room layout, but at least if we've got a port over here, I'll just draw this in pencil real quick. Okay, so let's say we've got a port right on the wall right there. Okay, and so we run a couple of Ethernet cables over to those two computers. Okay, now this is somewhat inconvenient. If this guy wants to walk around the desk this direction, he's going to be tripping over cables unless we put him inside of some sort of a cable run that goes across the floor. There's ways to protect it, but that could become a potential hazard. However, he does have this way that he can walk around the desks to the door, and so our traffic is kind of minimized. Now, in a middle of the room scenario, there really is no best case. You know, this is really not ideal to have desks set up in the middle of the room. Okay? But if this is the case, I might even suggest just middle of the wall right here on this room. Okay? Now, middle of the wall across from the door kind of works as a general rule of thumb for most offices. So let's just think here. So across from the door, middle of the room, doesn't really work for this guy because he's got his desk facing the door. So maybe we want to move off to the side. This room here, we've got a desk that's in the corner. So in this case, this is perfect. If we put a drop either in the corner here or across from the door, middle of the wall, that's going to work perfectly for this guy here. All right, let's look at a couple of the other offices. This one here, again, here's my door, middle of the opposite wall. Again, cuts off that walkway, but he does have the option to go around the desk the other way. Let's start over here. So here's my door, going across to the opposite wall. Again, if I put a drop there, that's not too bad. Here's my door, cross middle of the wall. Again, it takes out one of his walking paths, but possibly a good option. Now, the question becomes, do we want to plan where the network ports are based on the way that the offices are configured, or do we just want to follow the same rule of thumb of we're going to go to the wall across from the door and we're going to go to the middle of it? Well, the reality is people are going to move their offices quite frequently. Sometimes they determine the layout of their office based on where the power outlets are, where the network options are. So there's really no wrong way to do it, unless you do it intentionally wrong. So for example, if I were to put my network drop right next to the door, okay, so that no matter where I go, I'm going to be crossing that cable. Unless somebody puts their desk against the same wall, that cable is going to be going across a walkway. So that's the one place that I wouldn't recommend putting it in. Other than that, you can kind of go almost anywhere in these rooms, but typical rule of thumb, go to the wall across from the door, put it in the middle. Something like that. Now, in a more complicated room like this one here, well, see, I've got 8 computers in this one office, and I've got 2 doors. Fortunately, they're on the same wall. So if I were to go to the opposite wall and go in the middle, this isn't actually too bad. Okay, I can run a whole bunch of lines into my cubicles across this path here, and most of these people are going to head directly to a door. They're not necessarily going to walk around. This guy, for example, if he's trying to get out of the room, he's not going to walk all the way around. Now, there is going to be some traffic here. Maybe this guy wants to come over and talk to one of the people over on this side of the room. So there might be a little bit of traffic there still, but that's not a high traffic area as far as this room is concerned. So that might not be a bad idea still, following that rule of thumb. There's going to be a couple of tricky spots in this one. For example, I've got this secretary's desk. This is a greeter or somebody who's going to be welcoming people into the building or just making sure that the right people go to the right place. So how do we get networking to this particular person? Well, of course, we've got this wall here, but if this is an exterior wall, it's possible that it's cinder block, possible it's concrete, so we may not necessarily be able to get a wire drop in here, but if we can, ideally, of course, we'd want to stick it there. Otherwise, we might have to stick it somewhere along this interior wall and run a cable track or something so that this person's not constantly stepping on it or breaking that. Again, very rarely do we actually want to come up through the floor in the middle of the room. If this is a cubicled office, it's possible that it might not be a bad idea to bring it up through the floor in the middle of the room. But if they ever decide to switch the cubicles to kind of facing the exterior wall rather than all facing the interior of the room, all of a sudden, again, we've got the same problem of those network drops are not very conveniently placed. So think through the traffic for these wired runs. Where do we actually want to put stuff so that we can get wired runs? Now that's coming up from the basement. Now if we're coming from the ceiling, a lot of the same is still going to be true. The difficulty is, where are we running? Now when we go down into the basement, hopefully there's nothing there. We can kind of run around the outside of the building. It's not a big deal to do that. But in the ceiling, realize that these walls are most likely going to be floor all the way up to the ceiling above the drop ceiling. So we can't necessarily go along the office space as we could in the basement. We're going to want to get into this hallway where hopefully there's no obstructions. We can kind of get all the way around the offices through that. But we're going to have to punch a hole into each and every one of these offices through that wall. And again, we're still going to want to cross all the way across that office and then drop down on the far side so that we're out of the traffic area that's created by that door. So let's say that we get some runs planned. Now, I'm going to use some green here. So let's say that I decide I'm going to start running stuff into the hallway here. And then I have a run all the way down here. So then I've got a run that comes in here and we'll go right there. This guy comes in and drops right there. This one, see this one I might change because it's a corner office and there's likely some windows or something here that either somebody wants to have facing them or something. This guy we might just run right to the wall right there. This guy here, this is another tricky one again because we're going to go to the far side, but we're going to end up coming back to the middle of the room for however many computers we have on this table, and we're going to have to cross at least one traffic point, but we're going to go ahead and put that there. All right, so we got this guy here. Again, got a network drop there. Now, you'll notice in this office where we've got 3 computers, we might not want to put 3 right on this wall, especially because we've got people on every single wall. We can go ahead and maybe put put a drop right here that's going to service these two computers, or put a drop here that's going to service these two computers. We can get creative with where we want to put those ports in, but the thing that we do want to remember is that we need to have enough wired ports for each computer in each room. So this one, even though I've got one line drawn in here, I'm going to actually have 4 ports inside that one box for these 4 computers. Again, we don't want to have a whole bunch of switches inside each of these different rooms. So we want to be thinking through where can we put stuff that makes sense. I'll go ahead and draw that one there. So that takes care of that. Now I'm going to leave the rest of the map clean for just a moment, but we've got all of these different drops into all of these different rooms. You know, and this guy's going to have 3 in here. This guy's going to have 4 in here. It is easiest if we're running a bunch of cables kind of together in the same thing. So instead of running a different path for every single drop, you know, it's good to bundle things together so that we can get them more efficiently to a location. Even this one here, rather than having a drop on each and every wall, we're doing 4 drops to this back wall here. That just simplifies things quite a bit, keeps our work to a minimum, and it still provides the service that we need to provide to this particular room. So we're going to plan this out. Now, as we plan this out, we need to keep in mind that we're going to run into obstacles. No plan is going to go perfectly unless it's new construction, and even then, things don't really go as according to plan every time. So we may have to modify this, you know, and for example, they might say, oh, by the way, we're adding a 4th person into this room, or hey, we're going to add a 3rd person here, or this room actually doesn't need a network connection, or we're going to put one there anyway because someday you might want it. When we're going to run all this stuff, we might as well do all of it now. It's going to be much more cost effective to run it all up front rather than trying to add stuff in later. So we're going to make a wired run to each and every one of these offices, and we might even go ahead and say, well, there's 3 people in this office, we're going to go ahead and put 4 drops in there. There's 4 people in this office, put 4 drops in there. Maybe we'll put 4 drops in every single office that has multiple people, just so that we're prepared in the event that more people or one person with multiple devices wants to be in there connecting multiple devices up. So we've figured out all of these paths to each of these different offices. Then we're actually going to run those paths. Now at the end of each of these paths on the wall is going to be a keystone jack, okay? Something that we can actually plug in our wired Ethernet cable to, something that's permanent. Okay? We're not going to run a cable out of a hole in the wall over to a computer. We want a place where somebody can plug a new Ethernet cable into and get that connection to their computer. Okay, so here comes a question that we kind of need to know. How long are all of these cable runs? Okay. Now, because I don't have written on here the different the dimensions of each of these rooms, we kind of have to guess at what size they are. In the real world, you would definitely want to measure. Let's just say that this is a ridiculously large building and that each of these offices is something like 50 feet wide by 75 feet. Well, if each of these offices is 75 feet wide, you know, we got 75, 150, 225, and maybe a little bit more here, but 300 feet. Well, 300 feet, roughly 100 meters, that's the maximum distance that Ethernet can run. So there's no way that I'm going to be able to get from this demarcation point to anything further than about right here on the hallway. Now, yes, if we have a basement, we might decide to run the hypotenuse of the triangle and try and reduce our distance. We might be able to get a little bit further down this hallway, but we're going to run into some length issues with our cables if these are each 75-foot wide offices, which fortunately they're not. But we need to start thinking about that, okay? If, let's just say, these were massive offices, this is a huge building, how do we then get the internet to all of these computers, especially the ones that are all the way across? Maybe this is 500-600 feet from our internet connection all the way to this break room down here. Well, how do we actually get from there to there? Well, we've got a couple of options. We could run fiber from one end to the other, which would be a little bit more expensive. We'd have to figure out how to adapt the fiber to Ethernet once we got over to these other remote locations, but that would resolve our distance issue. Or we could start thinking, well, how could we get a switch or a hub closer to our endpoint connection? So we've got this room here. Maybe we could run fiber to this room here and then branch out with a switch there. We'd use this as a second telecommunications room. Okay. So the cabling from a telecom room out to the endpoint offices, we call this horizontal cabling. A connection from one comm room to another comm room, this would be vertical cabling is what we call it. That term comes, if you think about an office building with multiple floors, each floor is probably going to have its own telecommunication room. So the horizontal cabling from that telecommunication room would be all the connections on that floor, and then the vertical connection would go to the floor above it to the next communications room. It works in a two-dimensional or a single-story plan as well. It's still going to be vertical cabling from comm room to comm room. But if we can run that distance, well, maybe then this comm room can kind of service everything on this half of the building, and this comm room can service everything on that half of the building. Fortunately, these offices are probably no more than 20 feet wide. So if they're 20 feet wide, from this comm room, we've got 20, 40, 60, 80, 100 feet, 120, 140, 150. Roughly, we've got 150 running along the perimeter of this building. So that's not too bad. That's well within our 300 feet or roughly 100 meter line. Now, in structured cabling, I should mention that 100 meters is the maximum distance for Ethernet. However, in our structural cabling, we actually want to stick to 90 meters. Okay, so the maximum length of an installed cable from a patch panel in our demarcation room to a keystone jack on the wall, we're going to say 90 meters. Well, you say, well, why is it 10 meters shorter? Are we worried that it's not going to be able to make the distance? Well, the reality is, on this side, where we've got it punched down into a patch panel, there's going to be a cable from that patch panel over to a switch. And in the office, from the keystone jack in the wall, there's going to be a cable from the keystone jack to a computer in the office. And the length of those cables is added to our total length. So if we were to run, let's say a 99 meter run, that only gives us about 3 feet for a cable in the comm room, and then we've got no more extra length in the actual office to run a cable. So we say 90 meters so that we have about 10 meters of play, or about 30 feet, which makes sense. Most comm room cables are going to be fairly short. They're going to be 3 meters or less. Okay, so 9 feet, 10 feet roughly on a cable. So that leaves us 7 meters, or roughly 20, 21 feet in the offices to run a cable. And if the length of this office is 20 feet, that's a reasonable amount then. We shouldn't have to have a cable longer than 20 feet inside of these offices to get to their computers. Now, of course, 90 meters is our maximum. All of these runs, based on the size of this building, are going to be far less than 90 meters, so we shouldn't run into that problem. But if you're working on a larger project, or you've got some ridiculous runs, like maybe our comm room has to be in the corner of this building, and we're trying to go all the way around the perimeter to get to a point over here, now that's going to get pretty close to our 90 meters. We need to be thinking about that. Okay. All right. So I've planned my cable runs. What's next? All right. From a physical standpoint, the other thing that we need to be thinking about is running wires for our wireless connections. Okay, so not just the wired keystone jacks, but realize every wireless access point also has to have a wired connection. So let's talk about planning wireless for just a moment. Okay, now, where do we need wireless in the building? Now, in today's world, people kind of assume that there's going to be wireless connectivity everywhere. So we might need to start thinking, let's put wireless all over the building. Okay, now, well, what does that look like? Well, it depends on the type of wireless access points that we're using. If we want to use the lower range but higher speed, kind of 5 gigahertz wireless access points, we might actually stick a wireless access point in every single office. Or maybe we want to have a little bit more broad coverage. So we have a combination 2.4 gigahertz, 5 gigahertz, wireless AC or wireless AX wireless access points. And maybe we stick those kind of in the corners of the hallway to kind of cover each of these different quadrants. You start thinking through, what is the actual range of the wireless access points? How many devices are they designed to service? And there is a ton of variety in wireless access points today, from cheap wireless access points that are only designed to handle 5 to 10 clients to more expensive wireless access points that can handle 60 without a problem. There are wireless access points that are out there that you could probably put one right in the middle and it would be able to service the entire building, but it wouldn't necessarily be the best way to do it. So let's start by assuming that we want to focus on some of the high wireless traffic areas first. So this break room, for example, down here in the corner, there's not any desktops, there's no wired devices here. But it's going to be very common for people to bring their phones into the break room, tablets, laptops. So here's a location where our wireless might be more important. Similarly, the conference room right across the hall from the break room, people aren't going to bring desktops in here. They may, and the company may put a desktop for presentations in this room. It's very uncommon. Most people just bring laptops in, plug them into a projector or something like that, or maybe this is a TV on the wall over here. But this is going to be another area where wireless is going to be fairly important. It's going to be a conversation with the tenants of this building to see where else is wireless important. Now, the reality is, when you ask somebody, where do you want wireless, they're going to say everywhere, obviously. So you as a planner need to start thinking, well, what does that really mean? How many people are in a particular area? For example, over on this side, there's only one person per office in all of these offices here. And even this office here, it looks like it's one guy. He's got a table with maybe some chairs that people can come in and visit. So this side may only have 4 people or 5 people in the offices over here, where a more dense location like over here, we've got 4 people here, 3 people here, 2 here, 1 guy over here. We might have a lot more devices in this particular area. These guys here, definitely going to have lots here. So we need to start thinking, where do we need to put wireless access points so that each of these devices can get a solid connection with good service? Now, because this break room here is going to be a high wireless area, I'm going to go ahead and put a wireless access point here. So I'm just going to write a W with a wireless access point. Right there. Okay. Now, some other locations, we talked about the conference room. Conference room is going to be very important for wireless connectivity, and I might want to put it on the ceiling in the middle of the conference room so that the people all around kind of get good wireless signal. So there's my W there. Now for the other offices kind of around the perimeter, now this wireless definitely going to service this guy over here. So we may not have to worry about this office here, and depending on the wireless access point that we get, one of these two might actually cover this office as well. But just to be sure, maybe I want to put some wireless nearby this office. We'll come back to that in just a moment because I want to start thinking about these offices over here. And we've got lots of people in these offices. Where do we want to actually put it? And maybe we want to split the difference. Maybe we want a wireless access point kind of in the hallway, middle of the hallway there. So this one will kind of service this office, that office, extra wireless for the conference room if we need it. But how far does that wireless really go? Does it reach all the way to the corner? Maybe, maybe not. Maybe we want to add a wireless access point either just in the hallway or inside this room here. So we've got that guy, we've got this room here. Maybe a wireless access point middle of the hallway over here to cover these guys. Coming over to the corner. So again, this wireless access point's probably covering those guys, but let's go ahead. Let's put another one inside the office, and you'll see that there's this pattern kind of emerging. Looks like I'm putting one on each of the hallways kind of halfway down, and then one kind of in each of the corners. Okay, so let's see what would happen if I followed that pattern around. So there's that one there, put one there, and then maybe we'll leave that one for now. Okay, so now if I look at each of these offices, this guy's definitely covered. These guys are covered from that guy, so on and so forth. And you're saying, well, how do I know that they're covered? Okay, how do I know that this wireless access point is going to service these? Again, if I look at the range of this wireless access point as published online, it might say something like 100 meters of range, or 25 meters indoors, or 75 feet indoors. 75 feet, that's going to cover most of this building just based on the sizes that we've been discussing. But realize that wireless performance degrades the further away from the wireless access point we get. So I really want wireless as close to my computers as possible. If I use this wireless, it might cover all the way to this computer over here or this computer over here, but it might be terribly slow on those two sides, especially if you've got all these computers in the middle kind of stealing that bandwidth and using up what's there, so these guys barely have any connectivity whatsoever. So instead, what I'm trying to think here is essentially let's go 1 to 2 walls away. So this wireless access point goes through one wall, 2 walls and kind of stops after that. Okay, so it'll cover 1 wall, 2 wall, it'll go here, but it won't go any further than that. So that's kind of how I'm planning, is kind of this 2 wall rule. Not that the walls are necessarily going to stop the wireless signal or cause it to deteriorate so far that it's not going to work, unless these are cinder block walls or concrete, steel reinforced concrete with lead-based paint on them or something. The walls aren't necessarily going to stop the signal so much as I just want to make sure that I'm close enough to each of these computers. Now, if money's not an object and you can afford to do it, by all means, put a wireless access point in every single room. Use some of the high performance 5 gigahertz bandwidth wireless access points. Go ahead and put one in every single room so that you have the best coverage that you can. If these are 2.4 gigahertz wireless access points, don't stick one in every room, because the 2.4 gigahertz bandwidth, we're going to talk about channeling in just a moment, you're going to interfere with all of the other ones, and you're actually doing more harm than good by spreading them out. But if you've got some short range or some 5 gigahertz wireless access points, sticking one in every room is going to give you great coverage. But in this way, so let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8 wireless access points right now. For an office building with some 32 computers or 15 offices, 8 wireless access points is really not that bad. I might even stick a 9th one right here, just so that we have that secretary's location covered. 8 or 9 wireless access points, not too bad for a building this size. Might be a little bit overkill, and you might be able to get away with removing 1 or 2 of them, or maybe you say, hey, we don't need one in the conference room, we'll just depend on the one that's out in the hall, or maybe we don't need this one up front, or there's a variety of different places where we could say, well, let's pare it down to 5, or let's pare it down to just 4 wireless access points, and you put 4 in each of the corners of the building and try and cover it that way. But this is kind of my idea of what I would say. Let's get some wireless so that we're servicing 1 or 2 offices with each and every one of these wireless access points. Okay, get some good coverage there. All right. Now these are all going to be either mounted on a wall or on the ceiling, but we need a wired run to each and every one of these. That's how we began this conversation. So again, using my track that already exists, it's not too bad to go ahead and just add in a couple of lines for each of these different wireless. Now, if we carry this around this direction, we can wire up all those offices, those wireless access points, and so on and so forth. But that's not too bad. Now let's talk about channeling for just a moment. So in 2.4 gigahertz wireless access points, there are 11 channels, 1 through 11. Each of those channels actually covers a frequency range that covers channels on either side of it. And so channels 1, 6, and 11 are the only ones that don't overlap at all. Okay, and so we want to kind of set these up to 1, 6, and 11 so that they don't end up overlapping and causing interference. So the way that that's going to look, I'm going to start over here, and I'm just going to say this one is going to be a channel 1. Okay, so now how do I channel these two, which are my closest neighbors, so that they don't interfere with channel 1? Well, this guy becomes a 6. And this guy could also become a 6, but he might interfere then with this guy over here. So I'm going to go ahead and make him an 11. Okay, so there's a 1, 6, and 11. So these 3 access points, even though they are in range, they're not going to interfere with one another, and they're going to cover this area very nicely. Okay, so now we've got this guy down here in the corner. So he might cross over with this 6 here. So we're going to go ahead and make him an 11 there. This guy here, we've got a 6 and we've got an 11. So let's go ahead and make him a 1. I'm going to go around the other way. So we've got an 11 here. This guy could be a 6 or a 1. Either way. Let's just think ahead a little bit. If I make him a 6, then I would make this guy a 1. That guy an 11. Let's see what that looks like. So if I make this guy a 6, this guy would be a 1. So we got 1, 6, 11. This guy would be a 6. And then this guy would be an 11. Okay, so there we go. So we've got a couple of 1s, a couple of 6s, a couple of 11s, and that's just the 2.4 gigahertz channel that they are on specifically. But the reason for that is so that they won't interfere. And so the 6 won't interfere with the 11s or the 1s, etc. Now, because this is a fairly small building, we are putting 9 access points in here, 8 or 9 access points. There's a potential that this 6 and this 6 are going to overlap ever so slightly, and this 6 and this 6, for example. But at least the interference is going to be significantly less than if we had all of these access points on channel 1 or all on 6 or all on 11. So that's going to be our proper channeling. So we're going to go ahead and plan that out a little bit. Okay, so I'm still putting together a plan. Now, realize this is not a diagram specifically. This is just my jotting down notes, ideas of how I want to put this plan together, what I need in order to get this working. You know, the fact that I'm going to have 8 drops or 4 drops in each of these locations. And so I might even add just some numbering in my planning, like this is 4 Ethernet drops, this is 4, this is 1, maybe this is 2 or 3, or maybe I just say I want 4 in that one. This guy's 2. 2 here, 1 here, and I'm just going to go around and start planning where I want my Ethernet to go, how many connections I'm going to need. And as my plan kind of comes together, I can start to include other information that comes up. You know, are there barriers to what we're doing? Maybe there are walls that we can't breach either because of the material that they're made out of or building codes or something like that. We can start to think about what are we allowed to do, what are we not allowed to do. But I want to put this plan together so that I can kind of get in my head what we're going to end up needing in the long term. So once I've put this plan together, I need to actually implement the plan. So I go to the site, I actually have to start putting holes in walls, putting stuff together. So how am I going to do that, or what's my process going to be? Well, the first thing that I'm going to do is, starting from my demarcation point, I'm going to start clearing a path. I'm actually going to make sure, can I actually get everywhere that I need to go? Now, hopefully this building is unoccupied or minimally occupied while I'm doing this work, and I can remove a whole bunch of these ceiling tiles without annoying too many people, so that I have kind of this clear path to all of these different locations. So clearing the path to all of the locations, making sure that the runs that I have planned are actually possible, is going to kind of be my step 1. Okay. And again, I kind of want to group my cables together. Now, there's pros and cons to grouping cables together. The pro is it's a lot easier if I only have to clear this one path and run all my cables along it. That's good. The downside is if these are all electrical cables, the more and more cables I get bundled together, the more electrical interference I'm going to have, the more crosstalk that I'm going to have. So I want to kind of be careful. I don't necessarily want to have more than 25 cables in a bundle. That's not a hard and fast rule. It depends on the type of cable that you're using, whether it's riser rated or whether it's shielded. But I want to kind of be careful about how many cables I'm running together. Or at the same time, it's a lot easier to run those things together. If I can get them inside of pipes, that'll cut down on interference. If I can kind of spread them out, maybe I can have a 2-foot area inside of this ceiling where I can run 10 cables in a bundle here, and 6 inches over I can run another 10 cables, and 6 inches over I can run another 10 cables. That might also help cut down on the interference. But eventually I'm going to want to run all of these wires to all of these locations. Okay. Now, in the demarcation or the comm closet room, I'm going to have what's called a patch panel. So a patch panel is just a convenient way of punching down Ethernet cables onto a panel so that I have a face with a whole bunch of female Ethernet ports that I can plug patch cables into and plug those into switches. Inside of each of these offices, I'm going to have a keystone jack punched down on the other side of the Ethernet, and it's going to be mounted inside the office, typically about a foot off the floor. So we're going to clear those runs. We're going to start planning how many wires are going to go where, and then we're going to actually start running each of those. While we're running them, keep an eye out for things like electrical wires. We don't want to run our Ethernet next to high voltage electrical lines. That's of course going to cause interference. We want to keep an eye out for other interference sources. We do want to make sure that we are protecting those cables. So either running them in a pipe or running them along a cable track or cable tray, something along those lines. We want to do that. Now, once we get into the offices, simply for aesthetic purposes, we're going to want to put those either in wall if we can, or inside of a cable track on the wall. We don't necessarily want wires, coming up through the floor or dangling down from the ceiling that are just bare wires. We're going to label the cables. This is critical. As we're running each of those lines, we need to label them so that we know which cable is which. We're going to terminate the cables in the comm room. We're going to terminate the cables at the keystone jacks, the service locations, and then we're going to test them. And we're going to plug in a tester. We're going to make sure that all of the wires have continuity between both locations and that they're punched down in the right order. It's a frequent mistake to get two wires switched around, and so you'll be looking at your tester and it'll have two wires that are crossed. We'll need to repunch those down, or you'll have a wire that's broken. If we're pulling these through piping, you got to be careful about how much force you put on the wire. You put too much force on the wire, you can actually stretch the copper inside of it, or you can actually twist it and cause it to break. And if you break one of those wires, doesn't matter what you're going to do on the end points, it's not going to conduct an electrical signal. So you want to be careful when pulling it, and you definitely want to test it to make sure that each of those runs are good on both sides. Once we actually have networking equipment installed, let's say we've got some nice gigabit switches inside of our comm closet, we've got our computers out here, we actually want to make sure that if we have a gigabit switch on this end, we're getting gigabit connectivity all the way around. If you plug in a computer and it shows up as 100 megabit per second, or oh goodness, 10 megabit per second, it's probably indicative of a serious issue with the wire, either electrically or there's interference, or the length of the cable is significantly too long. So we want to double check that to make sure that we're getting the bandwidth that we would expect. And then finally, we're going to connect everything together with patch cables. So we'll run a cable from the wall jack to each of the devices, and in the communications room, we'll run connections from the patch panel to each of the switches. And if we've run Wi-Fi, the last thing that we want to do is walk around with a tool that we can measure the Wi-Fi signal and make sure that we're actually getting good Wi-Fi signal in all of our locations. We may need to add more access points if we're not, or adjust the channeling so that we can make sure that each location is getting a good wireless signal. Then we should connect to the wireless and again test the bandwidth, make sure that we're actually getting the bandwidth that we would expect in each of these service locations. So I hope that's been a helpful overview of kind of what goes into planning a physical network. Some of it's fairly elementary, obviously. We're going to start here, we want to end there, but there's really a lot to think about as far as how do we actually get from point A to point B, how many wires do we actually need to run. The more planning that you do ahead of time like this, the better off you'll be in actually implementing it, especially when you start to think, well, if I've got 4 lines in each of these different offices, each of those runs is 100 feet, well, that's 400, 800, 1200 feet. Shoot, I'm going to need a lot of cable in order to run that. So you can start to kind of add up how much cable you're going to need, how long it's going to take to run each of those, how many keystone jacks do you need in order to actually punch things down. You can start to put together a cost estimate from all of those things. But good planning is always ideal. So there's just an overview of kind of the things that I think through as I put together a network plan.